Hello students, today in this video we are going to discuss about the merge sort algorithm. In the last video I explained you the logic of merge sort, how the elements are going to be sorted by using the technique merge sort. Okay, for the same technique we are trying to write the algorithm here. You can write it in many ways, but the best method to write the algorithm is this one. Okay, so in this we are going to take help of two algorithms here. As I told you earlier that your algorithm should follow the logic here. Okay, the name of the variables can be anything, the name of the algorithm can be anything, the data types can be anything, whatever that you can do according to your wish. But the logic has to be followed here. Okay, so now I am going to explain you how the logic is represented in this algorithm. Okay, so the merge sort takes help of two algorithms here. The first algorithm is merge sort, the second algorithm is merge. As I told you in the last video that your merge sort will take help of two steps. We will perform sorting with help of two steps. Okay, what is the first step here? Dividing the elements, going on dividing the elements till you get single element in the division. The division is performed in your first algorithm. And step 2, in the step 2 we are going to merge, that is combining the elements while performing the sorting. The second step is explained in the second algorithm here. Okay, now let me explain you one by one. So here merge sort, I am passing some variables, that is low comma high. You know what is low and high, they are the positions. Okay, now I am taking low, mid and high. Till your low is less than high, you are going on dividing. Why we have written this condition here? Okay, you know that mid, low plus high divided by 2, that is nothing but you are dividing the elements into subgroups here. Okay, so and if you are dividing the elements to mid, what is your subgroups here? If it is this is your low and this is your high and this is your mid. What will be the subdivisions here? Low to mid one subdivision, mid plus 1 to high another subdivision. Same thing. Again this is going to be divided. Again this is going to be divided. Again this is going to be divided. Till you reach a single element. Now I am telling orally that you are going on performing division till you reach a single element. But system will understand this language? No. It should, we have to give some logic to identify whether the subgroup has reached a single element or not. Okay, so what is the logic used to identify whether the subgroup is having single element or not? This one. This is the logic used. What is the logic I have written here? Low should be less than high. I am saying that if your low is less than high, go for division. If this condition is failed, then don't go for division. We are saying that if my low is less than high, we are having more than one element in the subgroup. If this condition is failed, when this condition is going to be failed, when your low becomes is equal to high. I am not going for the subdivision. Why? Let me take one example here. If I am having 3 elements, 1, 2, 3, then what happens? This is my low, this is my high. It is having more than one element? Yes. Then low is less than high. Go for the subdivision. Now what will be your subdivision here? 2, 1. Okay. Now this one. Now this is my high here. Again it compares. Low is less than high. Yes, low is less than high. Again it thinks that no, it is not having single element. So again go and divide. Now I left with only one element. This is my low and this is my high. When your low becomes is equal to high, it implies that your group, that subdivision is having only one element. If it is having only one element, then stop doing the division. The same thing I have written here. Till your low is less than high, it implies that it is having more than one element. Go for the division. If this condition is failed, when this condition is going to be failed, when your low becomes is equal to high. When your low becomes is equal to high, when it is having only single element, then no need of going for the division. It will come out of the loop here. Okay, it come out of the condition here. Okay, now what are the subgroups here? Low to mid one group, mid plus 1 to high another group. After division, what you have to do? Merge. Merging is nothing but combining the elements here. Whenever it says merge, immediately control goes to the second algorithm. Okay, now what is this second algorithm? I hope the first algorithm is clear for you. It's nothing but simply you are going on dividing the elements till you reach a single element. Okay, how the single element is going to be identified means when your low and high both are positions becomes is equal, then it implies that your array, your subdivision is having only one element. No need of going for any subdivisions. Okay, till that you are going on subdividing the elements. When the subdivision is completed, now you are going for the combining here. Okay, let me explain how again the same logic is used to combine the elements. Now I am explaining you the second algorithm here. So once the subdivision is over, now we are performing the sorting and combining both at a time. Okay, in the last video only I explained you with the example, but I am trying to relate that example with this algorithm here so that the algorithm is more clear for you. Okay, as I told you earlier that your algorithm should satisfy the logic here. Okay, you can use any variables, anything, but it should follow the logic here. And what is the logic here? This one. This is the logic here. These are the terms you have to use. You can use any variables, any these things, okay, but you have to follow these logics here. Okay, let me explain this algorithm. Here I am using some number of variables here. A is a global array, B is a local array. I hope you know what is a local and what is a global, that you have discussed in the C, I think, in the first year itself. Okay, so this is actual array where we are taking the number of elements. This is a local array B I am taking, that is nothing but when I am doing sorting, I am taking help of a temporary array here. I am sending, when I am doing the sorting, that elements, the sorted elements for time being I am placing in the B, and finally I will transfer all the elements from B to A. Just for temporary purpose I am taking B, that's why I declared it as a local variable. Okay, now I am taking one more variable H here. This is my I and this is my J. Here I have written some condition while I is less than or is equal to mid and J is less than or is equal to high, do some transformation I am doing here. What is the transformation? This is nothing but I am dividing it as, for simplification, I am explaining this concept by taking as a cases. Okay, this is nothing but case 1. What is this case 1? Okay, these are, say for example, if these are the elements. What I told you in the last video, that first elements are going to be indicated by I, the next subdivision elements, positions are going to be indicated with J here. Okay, let's say the elements positions are 0, 1, 2, 3, 4, 5. Okay, this is nothing but your low. Okay, this is nothing but your mid. This is nothing but your mid plus 1. This is nothing but your high. The same terms in the last video we discussed. It is nothing but I is equal to low. Your J is nothing but your mid plus 1. Okay, so this is the positions. Okay, now what he is telling, while I is less than or is equal to mid and J is less than or is equal to high, it implies till my I is in this subdivision, till my J is in this subdivision, I am going to perform that exchange. What is that exchange? It is nothing but, you can observe, if A of I is less than A of J. What is A of I here? 3 is less than 4. What happens? What you are doing here? I told you that when we are doing the sorting, the elements, the temporary elements are going to be stored in B. A of I is equal to B. It is nothing but now my B array will be is equal to 3. It is nothing but simply we are comparing A of I and A of J. If A of I is having less, then B, that value will be sent to the B. Sorting is over. If the sorting is over, what happens? I told you that you have to increment the I value by 1 to indicate the next element. The same thing we did here. After transferring A of I, you have to increment I value. Say for example, if we are going for the next case. What is the next case here? Again you have to compare A of I and A of J. Which is having the less element here? A of J is having the less element. Now you have to transfer this element A of J to B. Else, if A of I is less than A of J, transfer A of I to B. Else means A of J is having less. A of J is less than A of I. Then what you have to do? A of J has to be sent to the B. And what is the next step? J is equal to J plus 1. It is nothing but you are trying to move to the next element. Because sorting of this element is over. So your J is represented, J represents the next element. How you are going to represent the next element means J is equal to J plus 1. This process goes on. Again compare A of I, A of J. Which is having less? Now this is having less, I. Then what you have to do? Again increment I by 1. Like this the process goes on. This is explained in this case 1. Case 1 is simply nothing but compare A of I and A of J. Which is having the less value, transfer that value to B and increment that position. If A of I is less, increment I to indicate the next position. If A of J is less, transfer it to B and increment J to represent the next position. This is about your case 1. Apart from this, we are having few more conditions. Okay, this is second one. This is nothing but your case 2. After doing the sorting, I told you that the elements can be left in any subdivision. Okay, if I am taking 2 subdivisions, first subdivision's elements can be completed, but second subdivision there are some elements in the second subdivision. Or second subdivision element sorting is over, but few elements are left in the first subdivision. The 2 cases are explained. You can't write that the elements left in the first subdivision, the elements left in the second subdivision in the algorithm or in the program, because your computer won't understand the normal language. Okay, some logic should be given here. Okay, so what is the logic here? I am writing if my I is greater than mid. What it implies? When your I becomes greater than mid. Okay, let me take one more example here. Let's say that 3, same 3, 7, 10 and this is nothing but your 11, 15. What it implies? First, this element is going to be placed in B. B is equal to 3. Next, this element is also going to be placed in 7 and this element is also going to be placed in 7. But first this is I, next incremented. When the elements are over, what happens when you have written I is equal to I plus 1, I enters into the next subdivision. That is nothing but this is your mid. How your system identifies that the elements in the first division are over. You can't write it in a normal terms. What is the logic here? When your I becomes greater than mid, it indicates that the elements in the first division are over. So what we have to do? As I told you in the last video, if one subdivision elements are over, blindly you have to transfer these elements to the array, because already these elements are in sorted order. The same thing I have written. If I is greater than mid, it implies that the first division elements are over. Then what happens? From j to I. You have to transfer the elements from j to I here. I am taking one more variable, that is k, that is j to I. What you are doing? Simply you are transferring that elements to b without any confusion. Okay, this is nothing but your case 2. Then if, say for example, my first subdivision elements are there but my second subdivision elements are over, then what happens? See here, if the first subdivision elements are over, if this condition is not satisfied, then you will enter into else. What is there in the else here? Else means your second subdivision elements are over now. Your first subdivision elements are there, but your second subdivision elements are over. So that is nothing but your case 3. Okay, let me take the example here. Same 11, 15 if I have taken, and 3, 7, 10. What happens? This element is over j. Now j is moved here. This element is also sorting over. This element sorting is also over. Now few elements are left in your first subdivision. So what it will do? Simply, okay, if say this is I to mid, k, I to mid, these elements are going to be transferred to b. So the sorting is performed in the 3 cases. Case 1, normal sorting, compare a of I, a of j, which is having the less, push the element to b. Case 2, if one subdivision elements sorting is over, but still there are some elements in the other subdivision. If the subdivision is second subdivision, then take k, j to I, transfer the elements to b. Case 3, if the first subdivision elements are there but the second subdivision element sorting is over, then what you have to do? Transfer these elements to b. 3 cases over. Now my b contains all list of all sorted elements. So last one, for k is equal to low to high, simply transfer all the elements in the b to a, because my original array is a. b is used only for temporary purpose. Now the sorting is completed here. You have to follow this logic, that I is less than or is equal to mid and j is less than or is equal to high. Which is having the less, transfer that element, increment that variable. If second subdivision elements are there, transfer them. If first subdivision elements are there, transfer them. How you come to know that the first elements are sorted, first subdivision elements are over means with the logic I is greater than mid. That's all. This is about the algorithm. Okay, you have to follow this logic and you have to write. The logic has to be there. The remaining names, variables, arrays, everything is according to your wish. Okay, this is about the algorithm. I hope this is clear for you. Okay, in the next video I'll try to explain you that is deriving the time complexity of the merge sort with the help of recurrence relation. The expected question in this merge sort is, I told you in the last video that in the merge sort we are going to see the example, algorithm and time complexity. In the maximum times in the external examination, he asks you to derive time complexity for the merge sort. That is the most important topic in the merge sort. Okay, I hope this is clear for you. Thank you.